Welcome back. It's time for video 2 as we continue our work in Unit 5. This video basically takes us into the divisibility rules as we take a look at what's going to go on in our unit. So let's go ahead and share this PowerPoint. Okay, so it's time for divisibility rules. And again, as I said previously, your author includes a divisibility test for 7 and for 11. I just don't care enough about them to even consider them. I put them in. We're just going to wave to that slide as we drive by. All right, so here we go. Let's go from the current slide. Okay. Shortcut ways to know if a given number is divisible by 2 or by 3 or by 4 or by 5. Obviously, some of these you do know, you're aware of. You know how to determine easily if a number is divisible by 5 or by 10 or by 2. So I listed them, but quite frankly, you probably already have those pieces of knowledge tacked on. So it's divisible by 2 if it's even, if it ends in an even digit. Okay, so that's the units digit or the ones digit. As long as it's even, the given number would be divisible by 2. It's divisible by 5 if it ends in a 0 or a 5. So again, if you read that mathy, the units digit is divisible by 5. It's either a 0 or a 5. So those are two you probably are well aware of. Divisible by 10, you already know that. It has to end in a 0. So if the units digit is a 0, 10 will divide the number. You may not know the one for divisibility by 3. Right? As it turns out, a number is for us to test whether a number is divisible by 3. What we do is we add the digits on the number, and the rule says if 3 divides the sum of the digits of the number, 3 will divide the number. For instance, on this stack, you see 18. So if we were to add the digits, that's a 1 and an 8, that's 9. So since 3 divides 9, we can now draw the conclusion that 3 would divide 18. So that's a pretty spiffy one for divisibility by 3. Divisibility by 4 works this way. You take the number, you create the number with the last 2 digits of the number, and if 4 divides that last 2-digit expression, then 4 would divide the given number. It's kind of hard to see here because they don't have very many big numbers. The last 2 digits, and if you look at 56 only has 2 digits. So if 4 divides 56, yeah, 4 will divide 56. Trust me, there's some better examples coming up as we take a look at the rest of this section. Divisibility by 6. A number is divisible by 6 if it's divisible by 2 and it's divisible by 3. So we'll have a double check, and if we can run that out, we'll find out whether it's divisible by 6. So for it to be divisible by 6, it must be divisible by both 2 and by 3. By 8, similar to what we saw on the divisibility by 4, except now you take the number, you form the number with the last 3 digits. And if 8 divides the last 3 digits of a number, then 8 will divide the given number as well. Divisibility by 9 is similar to the test for divisibility by 3. Again, we're going to add the digits. And if 9 divides the sum of the digits, then 9 will divide the number. Here's Dell setting up the hate for divisible by 7 and 11. I put them in. Your author does them. I just don't know that I would get too bogged down with it. I think it's very clunky. So there they are. So the PowerPoint looks pretty. All right, everybody wait. Good. There we go. Okay. So we got a big old number in the box. It's 112,440. And we're supposed to try to figure out, is it divisible by? All right. So first is 2. Well, you know what? It ends in an even number. So it is divisible by 2. So that one you already were good to go. You didn't need much help. Is it divisible by 3? Well, let's add the digits. We'll add a 1 and a 1, that's 2, and 2 more is 4, and 4 more is 8, and 4 more is 12, and 0 means the sum of those digits is 12. And since 3 divides 12, the sum of the digits, 3 will divide the given number. So problem 14 is another resounding yes. I purposely put 15 in this play in this order because remember, if it's divisible by 2 and it's divisible by 3, you guessed it, it's also divisible by 6. So without having to do any extra work for us on number 15, we get another yes. Same number in play. Is it divisible by 5? Yep, ends in a 0. That's all. If it ends in a 0 or 5, we've got divisibility by 5. So we're good on number 16. Is it divisible by 4? Here you go. Split out the last 2 digits. The last two digits are a 40. And since 4 divides 40, 4 will divide the given number. So yes, on 17, 4 will divide the number 112,440. 8 splits out the last three digits. In this case, that would be a 440. And I believe if I gave you a minute to think, 8, I do believe, will divide 440. So that means that 8 would divide the given number. So I think problem number 18 is another yes. Moving on. Is it divisible by 9? And again, we will add the digits. So we're going to add 1 plus 1 plus 2 plus 4 plus 4 plus 0. We did that previously. I think we got 12. Guess what? 9 does not divide 12. So that means 9 will not divide that given number, 112,440. So we get, it looks like our first no. Will 10 divide that number? Yeah, kind of think it will, because it ends in a 0. So 10 will divide the given number. So a little practice for us in terms of the divisibility rules. Probably not too painfully difficult for us. All right. All right. That takes us to the beginning of our first assignment from Unit 5, a selection of problems from the textbook. And you can grab some paper and sketch out some answers and shoot me some PDFs in the Dropbox, and we'll get started on grading. So that's assignment 5A for Unit 5. And that, my friends, ends video 2 for Unit 5. I'll be back shortly with video 3. We'll see you then.